Well, hello, pre-calculus students and seekers of truth. In this video, we will write a quadratic function in vertex form. So let's just recap what vertex form is. It's some constant m x minus h quantity squared plus k. All right, and we know that if we were to FOIL or multiply all of this out, it should equal this expression. But we need to somehow condense or compact f of x so that it looks like this. And so the strategy here is we're going to use completing the square. Okay, and it's going to get a little bit messy. But what we're going to do here is just alter this equation so that we don't change the values of anything. We don't change the graph. All we do is change the way that it's written. So we're going to start out saying that y, instead of saying f of x, I'm just going to use the variable y is equal to negative 3x squared plus 6x minus 5. All right? And then I'm going to try to, you see here, I'm going to try to get a perfect square expression here. I'm going to try to convert the right side of this equation so that it becomes x minus or x plus something. So I'm going to add 5 to both sides. So y plus 5 is equal to negative 3x squared plus 6x. And then I'm going to divide both sides by negative 3. So y plus 5 over negative 3 is equal to x squared minus dividing by negative 3, so I get 2x, right? And then remember, to complete the square, we need to sort of inject or add something here, right, so that we can factor the right side into a perfect square. And in this case, it's going to be 1/2 of this number squared. So it's negative 2 over 2 quantity squared. And that turns out to be something that we need to add to the other side as well. So negative 2 over 2 quantity squared. Okay. All right. So I get this thing that's pretty messy, but from here on out, we'll be able to clean it up pretty quickly. So this is just 1, right? Negative 2 over 2 is negative 1. Square that is positive 1. So I'll just clean this up. X squared, x squared minus 2x. X squared minus 2x plus 1. And then over here, we're going to have y plus 5 over negative 3 plus 1. Okay. And on the right side, this factors into x minus 1 quantity squared. And then on the right side, on the left side, we still have y plus 5 over negative 3. And now you see that the bulk of the hard work is done. I have this expression that I'm looking for, x minus a number. And then I'm going to move everything back so that I get y by itself again. So subtract 1 from both sides. And then multiply everything by negative 3. So I get y plus 5 is equal to negative 3 x minus 1 quantity squared plus 3. And then I'm going to subtract 5 from both sides, so we get y is equal to negative 3 quantity x minus 1 squared minus 2. Okay. And what this expression here is the same thing as the original expression, just saying that, if we were to multiply out everything, if we were to multiply everything out, distribute everything, then we would in fact get negative 3x squared plus 6x minus 5. But having it this way gives us some advantages. We know the vertex of this function, right? So the vertex will be at positive 1, negative 2. Okay, so that's one big advantage. We have the negative in front of here, so we know that it's a parabola that's going to open downwards. And we can actually graph a pretty good picture of this when we have it written this way. Rather than having it in standard form up here, has other advantages, but when graphing, it's quite hard. So There you have it, an example of converting from standard form to vertex form for the equation of a parabola. All right. We'll end this video here. We'll look at the general case in the next video. As always, thank you for watching and have a wonderful day.